I am Dr. Shailendra Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering. Today I am going to discuss the small signal analysis of IC 741, and you can remember few things like for the AC analysis we need to remember one thing, that for the AC analysis or small signal analysis we need to remember that we need to short circuit all the voltage sources and open circuit all the current sources. And if you will do it for the first stage, then you will get the diagram like this. So if you will replace it with the T model, then you will get that this resistor will be Re plus Re. So there will be 4 resistances, that will be 4 Re. So this current will be equal to the voltage which we are applying here, that is Vi, and this is the voltage which is applied between the transistor Q1 and transistor Q2. And in the whole circuit of IC 741, if you will observe, you have only 2 inputs where you can apply input, that is base of Q1 and base of Q2. So this IE is equal to Vi upon 4 Re. This is what which is written over here, and Re is the ratio of Vt upon I, and Vt is the volt equivalent of temperature, which is 25 millivolt at room temperature, and I we have already found out it is equal to 9.5 microampere, and it was the value which was obtained when we did the DC analysis of IC 741. And in the analysis of first stage, we have already find out this value IC1, and it was equal to 9.5 microampere. So if you will put it, you will get Re is equal to 2.63 kilo ohm. And if again I will go here, then you will see actually I have to find out differential input resistance, and this is the resistance towards output. So you know that towards input this resistance will be R pi plus R pi. That means this whole input resistance will be 4 R pi. And you know R pi is equal to beta plus 1 into Re. So you can write that Rid is equal to 4 into beta plus 1 Re. And from here we can draw one more important conclusion, that is, if this is the transistor, if you know resistance towards output side, then this resistance will be divided by beta plus 1, and if you know this resistance, like this is R pi and this is resistor Re. So if you know input side resistance, then it will get multiplied by beta plus 1 if you will see its effect towards the output side. And you can see here this current will be equal to twice of alpha IE, because there are two transistors which are providing current to Q5 and Q6. One is from the Q1, another from Q2. So this is alpha I, this is alpha IE. So this will be the twice of alpha I, that means alpha I flowing toward this side, alpha I toward this side. So this will be twice of alpha IE. And I naught is equal to twice of alpha IE, and you know transconductance Gm is equal to I naught upon Vi. So this is equal to, you know, I naught is equal to 2 alpha IE, and you know the value of Vi also. Vi is I into 4 Re. So from that you can Vi is equal to IE into 4 IE into 4 Re, 4 IE. So 2 to the 4 and this. So you will get alpha upon 2 Re, and alpha upon Re, you know, this is the value of Gm. So now you know values like Re is equal to 2.63, alpha is 1, Gm 1 will be this. So you can find out Gm1 will be equal to half of Gm1. Now let us talk about the output resistance. For the output resistance, you can remember this relation: R0 is equal to small r0 1 plus Gm Re in parallel with R pi, and you know all values over here. So if you will put, you can find out RO4 is 10.5 mega ohm and RO1 is equal to 6.7 mega ohm. And you know the transistors which will make the output is transistor Q4 and Q6. See, so in this way you can put, and now you know that these two transistors will come in parallel and their parallel combination will provide the output resistance of stage 1. So you have already found out these the value of RO4 and RO6. So if you will put them together in parallel, you will get output resistance. So now we can do its modeling, and it can be modeled as this. This is the model of the amplifier. So this is Ri, the differential input resistance, Vi, Gm1, Vi, Ro1, and this is the output. Now let us go to the analysis of second stage. We have did the same work in the sense that we have connected all the DC voltages to sorting them and then connected to the ground like this. And if there would have been any current source, then we need to open them. Now see here, I would like to explain few things, like this is Ri2, that means we want to find out the input resistance and output resistance. As we have already found out the input and output resistance for the first stage, same we will do for the second stage. In case of second stage, see, the resistance that will appear over here will be the R8 and that small Re, if I will replace it with the equivalent T model. Okay, this will be the R8. So this its effect over here, that means Ri17 will be the small Re plus R8, and effect towards input side will get multiplied by beta plus 1. So Ri17 should be Re plus R8 multiplied by beta plus 1, and same will come over here, and this resistance will become, or I can say R9 and Ri17 will be in parallel. And if I will replace this Q16 with a small Re by replacing it with the T model, then this whole resistance will be the Re plus R9 in parallel with Ri17 multiplied by beta plus 1. This should be the value of Ri2. This is which is written over here. This is the input resistance. This is the input resistance at the input side of transistor 17. R9 is this, and these two together, I can take different color so that, and these two will be in series with this. So we have written this, and it will get multiplied by beta plus 1, and this should be the value of Ri2. Now collector current IC is equal to alpha IE. So you can write IC17, that means this current will be equal to alpha V17 upon Re17 plus R8, and similarly we can write VBE17 by voltage divider rule and Ri17. So we have neglected RO16 because RO16 is much greater than R9, and you will combine these and we can get GM2 is equal to IC17 upon VI2. So GM2 will be equal to 6.5. So up to this point we have find out the input resistance. If you will put all the parameters, you will get it is equal to 4.4 mega ohm, and we have find out GM2. Now let us talk about the output resistance. See, what will be the output resistance? Output resistance will be the parallel combination of these two. So RO13B is the resistance looking into the collector of Q13B, while its base and emitter are connected to the ground. So we can easily write that RO13B is equal to small RO13B. So for IC741 values, we can obtain RO13B is equal to 19.9, and for this transistor Q17, this is the formula, this is the relation which we have already used in the first stage. So we can use it and we can put various values. So you can find out these values like RO17 is equal to 787 kilo ohm, and combining RO13B and RO17 in parallel, and you will get output resistance of second stage, which will generate the output resistance is equal to 81 kilo ohm. So now this will be the Thevenin equivalent of the second stage. Actually, we need this is the what we can say equivalent circuit of second stage. But when we will combine first, that means input, second stage and third stage, that time we will need this Thevenin equivalent circuit. That's why we are using this. So now next stage is the output stage. We have analyzed input stage, second stage. Now let us move towards the output stage. What can be the maximum value? Maximum value can be VCC minus VCC saturation minus VB14 if I will follow this path. Okay, if I will follow this path. Similarly, this VO minimum will be obtained if I will follow this path. Actually, it is connected to negative voltage, it is connected to positive voltage. Now, this is the modeling of second stage, and this is the modeling of actually third stage, and this is the input voltage for the third stage will be the output voltage of second stage, and we have already find out that VO2 is equal to minus GM2 into RO2 into VI2, where GM2 and RO2 are the transconductance and output resistance of second stage, which you have already find out, and GM2 was 6.5 milliampere per volt and RO2 was 81 kilo ohm. Now let us consider one example to find out the input resistance of third stage, gain, and few more things. Let us, how this is not the simple example, this is the actual analysis of the third stage. Actually, at a one time either Q14 will conduct or Q20 will conduct. Here we are assuming that Q14 is off and Q20 is conducting a current of 5 milliampere to a load RL is equal to 2 kilo ohm. Determine the value of R in 3. Indirectly, we are going to find out input resistance of third stage. Using GM2 is equal to 6.5 and RO2 is equal to 81 kilo ohm. These are the values which I have already obtained, and now determine the gain of second stage. So you know the input resistance looking into the base of Q20 is approximately beta 20 into RL. That means this resistor RL, if I will move towards this side, then it will get multiplied by beta plus 1. That means nearly equal to beta. So we can write beta 20 multiplied by RL. Actually Q14 is off, only Q20 is conducting. So it will come 100 kilo ohm. This resistance appears in parallel with the series combination of Q13A. So for Q13A, RO13A is R0, you know R0 is equal to VA upon IC. So we know these values, so we can find out it is equal to 280 kilo ohm. So the resistance of Q18 and Q19 network, this resistance is very small in comparison to 160, which we have already found out. So the total resistance in the emitter of Q23 is approximately equal to the parallel combination of this 100 and 280, and which is equal to 74 kilo ohm. So the input resistance of Rn13, that means we have found out this resistance, and now we are moving towards Q23. Here we have found out this resistance, which is 74 kilo ohm. Now if I am moving towards input side, it should get multiplied with beta plus 1, so which is nearly equal to beta. So this is how we can find out Rn3. That means the input resistance at the base of Q23, this will be the input resistance of third stage, and its value will come out to be 3.7 mega ohm. So we see that Rn3 is much greater than RO2, and the value of Rn3 will be the little effect on the performance of op-amp. So still we can determine the gain of second stage. So A2 is equal to Vi3 upon Vi2. From this, we can simply apply the voltage divider rule, and we can find out this, and A2 will come out to be minus 515. Now the open circuited voltage gain of third stage G VO3 is equal to V0 upon VO2. You know that it is almost nearly equal to 1, because this is the voltage follower stage. Now let us find out the output resistance. See, for this case you can do one thing, that you can take effect of various resistors. If you will consider effect from this side, if you are going towards output side, it should get divided by 2, it should get divided by beta plus 1. For example, if you will consider this, this is the output resistance of up to second stage. So after this, if you will consider it as RO2, if you will go towards output side, it should get divided by beta plus 1. If you will move from output side to input side, the resistance will get multiplied by beta plus 1. If you are moving from input side to output side, this resistance will get divided by beta plus 1. And this is Re23. If you will replace it with same T model, here this alpha E. So this is how you can find it out. Now from this resistance will become the output resistance of Q23. And from Q23, if you will move towards, from the input of Q20, if you will move towards the output of Q20, then this resistance would get divided by beta plus 1. As this is transistor 20, so it should get divided by beta 20 plus 1. And again, if you will replace it with the T model, then you will get it like this. So this is Re, so you can replace it with Re. If emitter is on this side, then you can draw it like this, but it will remain Re. So plus Re. So in this way, you can write R out is equal to Re20 plus Ro23 upon beta 20 plus 1. And you know these all values, like you know RO2, you know beta 23, you have value of RE 23, you can find out RO 23, which is 1.73. If you will put this value here, now you know RO 23, you know value of beta 20, you know value of RE 20. So you can find out R out, okay, and R out is 34 ohm. The second component depends critically on the value of output current. For an output current of 5 milliampere, RE20 is 5 ohm and R out is 39 ohm. Okay, to this value we must add the resistance of R7. So, which is included for the short circuit current production. I mean to say that I am talking about R7, which is 27 ohm, which is included for the short circuit current production. So, this value is almost equal to the specified output value of 75 ohm in the small signal analysis of IC 741.